Welcome to this introduction to 3D printing of houses in Singapore and around the world. 3D printing is rapidly transforming the way we design and construct homes, making building faster, more flexible, and potentially more sustainable. In this video lesson, you can pause at any time and ask questions related to 3D printing of houses. My answers will be restricted to the scope of this topic.
This is now the world's largest 3D printed community.
In this slide, we'll get an overview of where 3D housing is taking off around the world. 3D construction printing is no longer just a laboratory experiment. Several countries are already using this technology on real projects and small communities. First, the United States is a major hub. States like Texas, especially around Austin and Houston, have multiple pilots and full neighborhoods of 3D homes under development. In Europe, countries such as Denmark and the Netherlands are leading through companies like Cobod and Cybe, while Ireland has built some of the first council or public 3D houses. China was an early mover, with firms like Winsun showcasing large-scale 3D buildings, including multi-story prototypes. In India, early projects in places like Chennai and new rural housing prototypes are being tried out under various government-supported schemes. The UAE and wider Middle East, especially Dubai, have set ambitious targets to incorporate 3D buildings into their public works and city infrastructure. Finally, Japan is experimenting with soil-based 3D houses designed with high earthquake resistance in mind. Together, these examples show that 3D housing is a truly global development, with different regions testing how it can fit their local needs and conditions. In this slide, we will look at the main materials used for 3D houses. The first and most common material is 3D printing concrete. This is a specially designed cement-based mix that can be pumped through a nozzle and sets quickly. It is used mainly for structural walls and load-bearing elements. Next is 3D printing mortar. This uses finer aggregates than normal concrete, so it produces smoother surfaces and is suitable for detailed features such as curves, edges, or decorative elements. We also have fiber-reinforced concrete. Here, steel or synthetic fibers are added into the mix to improve tensile strength, reduce cracking, and increase long-term durability. Beyond concrete, there are polymeric or composite materials. These include fiber-reinforced plastics and other polymers, which may be combined with concrete to provide insulation, reduce weight, or form non-structural parts of the building envelope. There is growing interest in alternative and eco-friendly materials, such as recycled plastic, mud, or agricultural waste like rice husk, as well as soil-based mixes with lime and natural fibers. Finally, current research and development focuses on lower carbon binders, geopolymer concretes, and mixes that can capture and store carbon dioxide, helping to reduce the overall environmental impact of 3D housing. In this slide, we will look at some key companies that are driving 3D construction printing around the world. First, Icon, based in the USA, is one of the most visible names in this field. They develop large-scale printers such as the Vulcan series and have already completed more than 200 printed structures, mainly in Texas but also in other parts of the United States. Next is Cobod International from Denmark. Cobod supplies gantry-style 3D construction printers and is involved in a very high percentage of documented 3D buildings globally. Many other companies and contractors buy Cobod printers for their own projects. Apis Core, operating between the USA and Russia, focuses on mobile robotic printers that can be transported easily and set up directly on site. They are well known for very fast printing times for small houses. Another important pioneer is Contour Crafting in the USA. This company helped to introduce automated concrete printing concepts for buildings and has strongly influenced research and standards in the industry. Finally, we have Cybe Construction from the Netherlands. Cybe makes robotic crawler printers and offers a complete ecosystem that includes design support, engineering services, and training, helping clients adopt 3D construction more quickly and effectively. Now we will look at Singapore's initiatives in 3D construction. Singapore started exploring 3D concrete printing around 2018 now, mainly through the Housing and Development Board, or HDB. This work is done in collaboration with NTU, Robin Village Development, and the engineering consultancy Witteveen plus Boss. Together, they are testing how 3D printing can be safely and efficiently applied to public housing. There are already pilot applications in real HDB projects, At new estates such as Tenga and Bidadari, 3D concrete components are being tried out for items like benches, pavilions, landscape furniture, and special architectural features. These are good starting points because they are non-structural, but still allow designers to explore more organic and complex shapes. The goals for Singapore are very clear: improve construction productivity, reduce dependence on foreign labor, and at the same time allow more complex and customized designs in public housing projects. More recently, NTU has developed a carbon dioxide capturing 3D concrete printing process. In this system, steam and captured carbon dioxide are injected into the concrete mix while it is being printed. This locks carbon dioxide into the material, helping to reduce emissions and making 3D construction more sustainable for the future. In this slide, we will summarize the main advantages of 3D printing for houses. The first and most obvious benefit is speed. A 3D printer can complete the main structure of a house in a few days, instead of the weeks or months needed for conventional formwork, bricklaying, and casting. This faster shell construction allows projects to move more quickly to finishing and handover. Next, 3D printing reduces labor demand on site. Much of the work is automated, so we need fewer workers doing heavy, repetitive tasks. This can improve safety because people spend less time working at height or handling formwork and reinforcement. There is also strong cost reduction potential, especially for molds, complex shapes, and repetitive elements. Once the printer and mix are set up, printing another wall or another house is mainly a matter of time, not new molds or special formwork. Another important benefit is design freedom. The printer can easily create curves, overhangs, and customized layouts with very little extra cost, supporting more creative and user-centered housing designs. Finally, 3D printing offers sustainability potential. Through the use of low-carbon binders, recycled or earth-based materials, and even carbon dioxide, sequestering mixes, helping to reduce the environmental footprint of future construction. In this final slide, let's pull together the main takeaway messages about 3D printing of houses. First, 3D housing has clearly moved beyond the stage of small experimental prototypes. We now see real neighborhoods being built, especially in the United States and Europe, with new projects also appearing in Asia and the Middle East. This shows that the technology is becoming mature enough for practical use in different climates and markets. Second, Singapore is not trying to compete on large land areas, but instead is positioning itself strongly in research and development and in carefully selected public housing pilots. By focusing on productivity, reduction of labor dependence, and sustainability, Singapore aims to integrate 3D printing into its broader strategy for smart, green, and high-quality urban living. Looking ahead to the next decade, we can expect to see more hybrid construction systems, where the main structure is 3D and the rest of the building is completed using familiar methods and materials. At the same time, new mixes and eco-materials will be developed and building codes and standards will gradually become clearer. Altogether, these trends will make 3D housing a realistic option for affordable, customized, and environmentally friendly homes around the world. Thank you for listening. That is the end of this lecture. If you have any more questions, start my avatar below and you can speak to me just like you speak to your lecturers. Please keep your microphone off when you are not talking. I am very sensitive to background noise and can be easily distracted. Therefore, switch your microphone on only when you are speaking and press the mute button at all other times. Thanks. Bye.